Right, so this is straight off of, it's actually straight off of the web here, which is, I literally copied this and pasted it. Iterate with enumerate instead of range. Well, basically 11 tips to write better Python code. I presume I could actually play the video. There you go, be a 10-minute video, I guess. I suppose, I don't know if this will be 10 minutes or not. Mine might be a little bit longer. You always get tons of these tips and tricks. These ones aren't actually amazing, but anyway, I've copied this just with a copy, and I kind of like just pasted it straight into here and put spaces in. And I was actually just mentioning before that the block comments now, they are the same color as the single line comments in the Visual Studio Code editor, which is the editor that I'm using here. And in fact, what I shall do, because it's just reminded me, is zoom in a little bit so that the font is readable. There we go. That's probably massive, but that gives me a good 36 lines of code to work through. And I guess I work through these in blocks. So let's just, I wonder what the best thing to do is. Maybe I'll comment that, and each one that I comment, no, because I only want it once. So X, there we go. I'll move them out each one. So this is the first one, which is, and I will do a percentage that, which this creates a little block of code that can run sort of like on its own on the side. So iterate with enumerate instead of range of len x, and that's basically something like, but this is a really common one. You've got this anything that's an iterable. So you've got a list, say for example, 1. I'll do like 10, 20, 30, 40, 50. Right? And one thing that we can do is we can get the len of x like that. If I do control return, it will run on the side. I might shrink this a tiny little bit. I probably need to print this, print len of x, just over here like that. When it starts running, there we go. Oh yeah, it did do it anyway, but the len of x is 5, so if I do print len of x, we'll get 5 as well. So that's it. And by the way, this is very old school. I'm not sure if languages have a similar thing to Python in this way. Some do, some don't. There are ways of doing this, but the new convention is this is called an iterable, like this list. And the old way of doing, I'd never even dream of doing this now actually, but the old way of doing things would be like you'd write this for loop for I in range, and then len of x, right? And that's for I in range. So it goes from 0 to 5 basically, and then something like print, okay, and then x. And I presume if we did this would be the index of x. So the first item in x, because remember that list starts at 0, so this is a 0th item, so it's index 0, index number 1, index number 2. So this is kind of like, I'll comment this bit out for now. So this is kind of like the old school method of doing it. It'd be kind of like a C++ method, and even C++ has a way of iterating through lists. But if we do this and run it, then we get the, oh, there we go, not print x0, how about print x of I? You're probably looking at that for the last 2 minutes while I was talking. There we go, and we get our 10, 20, 30, 40, 50. Because I just printed x0, that printed 10, because that's the 0th element 5 times. Now that's the old method. The new method, or not the new method, the method that's been going on for quite a long time in Python, I presume since Python 3 started actually, is for I in x. That's it. And then print I. This will also iterate, oops, Control Z, because that's my IntelliSense working. This will also print the same thing. So that's what it's, and this is talking about enumerate, sorry. But I'll do this as well. We'll get a 10, 20, 30, 40, 50. We're going to get it twice now. The first one from these 2 lines and the second one here. But we can actually enumerate x. So enumerate x over here in brackets. And what's this going to do? Enumerate breaks up a list, or a list is it separates the index items, so it'll give you the index and the actual value. So now in enumerate here we've got the index and we want our value. So we can now print our index position and our value. And the index position, remember, the first index is 0, the second index is 1, the third index is 2, 3, and 4. And the values here are going to be 10, 20, 30, 40, 50. So instead of doing this, we've got this rather powerful thing. In Python, that's what it's talking about. And it now looks like this. So our first element here, our 0, is index number 0, and that's a value 10. Our second element here is of value is index 1, and it's got value 20, and so forth. Our last element is index 4, which is n minus 1, which is the length minus 1, because we're going from 0 to 4. That's our 5 components, and the final value there is 50. So that's basically it. I mean, if I saw someone doing this, there would need to be a pretty good reason in Python to want to have to do it this way anymore. It's literally not been like that for years. This is the modern way of doing things, and it's really, really handy. So we use the next one here, or list comprehension. Okay, again, if we do a percentage, and we'll actually put the little comment at the top, we use list comprehension. Did I cut it out? There we go, delete. So we go through them one at a time. I could even actually move this one right to the top there. There we go. So use list comprehension. So imagine let's just take our x again. I'll copy it down just for the sake of completeness, although we don't need to because Python already knows what x is from line 27. Line 27 being, if I can see this line over here, that's line 27, and line number 40 is just repeating it, that's all, for good measure. But use list comprehension in raw for loops. So it's something like y equals x squared for x in x. Now I probably don't, this will work by the way, and then we can do sort of like print y. Generally speaking, I like to do something like this, and again, how about that, I squared, not x to the power of x. And then for I in x, generally speaking, it's better to keep the indices and the variables different from the item that you're looping through, although it will work the other way. So I'm going to just print y there, and maybe I might even do it. You know what I might do? Well, actually, it comes out anyway. So let's just run that, and you know what? The first hash over there, or the first comment, comes in like that. It's quite nice because it comments the top line. So I will actually move this one down a line. It's quite nice because Python. So anyway, that was the second thing, which is use list comprehension instead of your for loops. And I think there's a speed advantage. We won't see a speed advantage here because it's going to take like 0.1 of a second or however long it takes. And actually, one hint I saw somewhere was use time.performance. So import time, and then t0 equals time, equals time dot time No, I think maybe it's perf, maybe perf, oh yeah, perf counter. Apparently this is faster. So I don't know why it's faster, because I always used to do this, which is t0 equals time dot time. This is for timing things, and then I get t1 afterwards. But I'll use this perf counter, but because time.time is the epoch time, the time since like 1970, number of seconds since 1970. this performance counter, I presume it just starts counting from now until the end. I'm not sure why it would be any better. Like logically, it doesn't sound like it'd be any better. But anyway, I should really put the counter here because the operation's done over here. T1 equals time dot perf. I've never used this perf counter, but obviously the time taken, time or print time, putting in quotes, time taken, something like T1 minus T0. And I presume, I don't even know if it's seconds or not. Let's have a look. We'll know if it's seconds or not because it will be like 0.001, which will be about right. So let's have a look. Yeah, it's 7 times 10 to the minus 5 seconds. So it is in, I think that's in seconds. In fact, if I hover over it, maybe it will, performance counter. And it doesn't actually say it, although it's a bit annoying. I was hoping it'd say what the units are. I'll stick it into. I started using Google Bard a lot. You can see all of my Google Bard stuff actually over here, like questions that I've asked, although that's hardly any questions at all. And what was I asking up here actually? Oh yeah, I wanted to, for some reason a legend was popping up somewhere in a matplotlib chart and I wanted to remove it. But anyway, time.perf counter in Python time module and hit the return button on it. Let's just see if it tells us it's. I could look this up. I'm like, oh, this is the. I can't assist you. How does time dot work in Python? Right. Hopefully that will work. Otherwise, I'll have to say that I'm not programmed to assist in that. I'll try that one again. Well, I think we can use an edit button. I wonder if that's really weird. Okay, might have to revert to. That's like bad response. Irrelevant, not factually correct, inadequate. If you can spell it, if I spelled that, I don't even know if I spelled it right. I've never seen that before. That's a bit of an odd one. It really is. Let's stick that into ChatGPT. The hero. I actually only revert to ChatGPT when Google Bard stops working. But let's just do a login there. And just continue there. We go and continue there. And stick it in. Right, okay, there we go. I wonder if it says what the units are. End time gives you the elapsed time. Finally, you can use. Finally, you can print elapsed time. You can. This is an example of start. You've got a start time here. You've got an end time here. Oh, it does say seconds there. Finally, it doesn't say anywhere else. It's the oddest thing that it didn't have it in Google Bard. I wonder if I just copy that and stick it into Bard. Maybe I have to kickstart it or something like that. Oh, there we go. Finally, it's. Anyway, I shouldn't have to kickstart an AI, not for something like that. I could have looked it up in the documents. But anyway, the point being that this is just like fractions, literally fractions of a second. So if I was to compare this to a for loop, and by the way, the comparable for loop would be something like y equals. Oh, what we'd have to do is we'd have to do y equals some empty array. This is the previous method of doing it, and then you do for I in x, and then something like y dot append I squared. So you'll be appending, and then again, and what I'll do here now, we've got the T1 perf count already done right over here, so I can just do this over here. I can just do a T2 just for comparables on times. They're going to literally be like fractions of a second each, but over here I've just got to do now T2 minus T1. So, and hit run. We can see again, like, you know, here it's in fact, if anything, this is actually showing that it's slower, but I think there's a gain if the index is much bigger. But right now that we're only going up to 5, so there's if anything, there's an overhead to getting the list comprehension kicking in. So this thing here is called the list comprehension over there, and this is just our for loop. There we go. So that's just our standard for loop. That was our, and the other one was our list comprehension. List comprehensions, but you'll see this a lot. But list comprehensions, you should use them kind of like as much as possible, but not too much. That's kind of like a contradiction in terms in itself. But basically, for simplest sort of things, or things that are like a line or two long, or where you can break it up and it's convenient and easy to use, list comprehensions are the way to go. But if it's something quite complicated, I prefer to stick it into a for loop. Like if you've got many things that are going on in here, it's often just easiest using a for loop. So it really just depends on that. But anyway, let's pick out the third thing. Sort complex iterables with sorted. Okay. X. Don't even know what that's referring to, but let's have a go. So let's get a complex iterable. How about this? That looks very complex. Oh, let's have to switch. We have to switch something around. There we go. 10. X dot sorted. Will that? No, that's sort. Okay, so let's do sorted of X. So I'm just going to say that Y equals sorted of X. And then I will print Y. I'm hoping that if I hover over it, return a new list. Okay, this returns a new list containing all items from the iterable in ascending order. So it's not amending the list in place. It's creating a new portion of memory where the modified list is. So, which I think basically I could probably show that, because let's just run it first. There we go, it sorted it because it was 50, 20, and the 50 and the 10 I flipped around, and now it's the right way around. But I think that if we had paste that in there, and then we did x dot sort. There are things, by the way, you can put like reverse equals true and stuff like that, but I'm leaving that out. Something like this. And here what I'll actually do is I'll print X, right? Now, when we run that, I printed Y and then I printed X, and we can see that X was untouched and Y was sorted. But here we can now do a print of X, and like I think it's going to be obvious, and that's the difference, by the way, between sort and sorted, is that we can see here that sort has operated in place. So tab, I always forget this, but it's in place, right? So this piece of memory that was allocated to X hasn't changed, so it's still there. We can sort of like show that with print the ID of X over there, and then straight after the sorting, and there's no reason why the ID would change in a way, I guess, but print ID of X over here. When we run it, we can see that they've got exactly the same identifications, even though we've operated on it and jumbled them around. So that's what it means to be in place. Same ID, basically. So we're going to have the same ID here, and we will have the same ID over there. Whereas if we print the ID of X here, let's just print ID of X further up and over on just the next line down. Copy that. We'll print the ID of Y. They will be two completely different things because it's sorting it to a different part of the memory. And there we go. There are two different things over here on the right hand side. So that's that so far. Let's move on to the next one then. No revelations at the moment. Store unique values with sets, and I'm not even sure what that is. X. Let's take that out. Delete. I know what the save memory with generators one's going to be. Ah, yeah. Okay. So imagine that we've got I wonder even if this will actually work. 1, 2, 3, 3, 3, 4. That's a set in Python. And if I do print X, what's going to happen is we should see that we just get 1, 2, 3, 4. So we've got the unique values. Any duplicates over there get thrown out, which is quite useful because I think, but I don't know for sure. I'm going to steal this X again from up here. Let's just steal it and put it back in down here. And then obviously we'd need a couple of dupes, 50 and 50. I wonder if, I don't know if I should do it there. I'll call this Y for now, because I have to do that. Okay. Actually, I won't. I'll call this X still, and I'll just do the same again. So that's our first version of that. Our second version is this, which is X equals the set of X over there, and then print X and run it, and there we go. The funny thing about this is so we got the 10, 20, 30, 40 and 50. Look at the order of it: 10, 20, 30, 40 and 50. Very odd that it doesn't do it, like it doesn't return any particular, you'd think it so like go, like logically you'll think it goes through, well that's unique, because if you're writing a piece of code to create a unique list, you would go through the first one and go, well that's unique, pass it into the list. We'd literally do something like this up here, where you'd keep appending the list with things that are unique. So that one will go in first, that one will go in next, then that one, then that one. Then it will check this one, that will go in, and then it will check this one, and it won't go in because you've already got a 50, and then it will check this one, and it won't go in because you've already got a 50 in the list. But it hasn't done that; it's just bunged it in any order. In fact, I don't know if I'll run it. If I run it again, yeah, it's a bit odd. Like it always seems to come out in that order. I wonder what would happen, for example, if I stuck in another 40. Will it change the order? No. So I don't know why that order's come about in that way. But obviously one thing that you could do, knowing that I'll put it on a separate line, but you could do X dot sort, because we want to sort that in place. Oh, can we not? I don't think I can sort a. I wonder if I can sort a set like that. Sorted. Can I do sorted on a set? Ah, yeah, there we go. Okay, and it's taken and it's got the unique values back out of it because these 40s. But I actually had to do sorted on it. That was the funny thing. Nevertheless, it's done. It's there. And again, if I did print ID of X, I think they'll be in different positions because this is returned. Well, it will do print ID of X, and over here we do print ID of X, and they're going to be in different positions in the memory. Yeah, they are. You can see two different numbers over there. I'm looking at the right hand side over here. There's two different numbers in the memory, so they're two different numbers. These represent different parts of the memory space, because remember, sorted is creating a new object, so it's creating a new part of memory. So remember, x.sort is in place, so that's in place, and this is new memory over there. So okay, we've done that one. Store unique values with sets. Okay, but this set thing's quite good because it guarantees that you can't duplicate. So it reminds me that I could use sets in certain places. But one thing about a set is, if we look at dictionaries in Python, which is hash tables, the keys are also unique. So, and if you do a duplicate key, I believe it's the second key, or the last key of any duplicates is the one that takes precedence. So, and maybe that, like, so this last 50 is the one that would be the one that takes precedence. But anyway, one way or another, it's unique. So we go and do the next one. Save memory with generators. That's going to be a harder one to show. Not too hard, but hard-ish. Hash percentage. So save memory with generators. So what was the example? Because I did have a great example before. Do I have to create a function and then return something? Def function. I wonder if that's the right way to go about it. And then here you do yield, because this will be a generating function. What I might do is I'm going to be really bad. Save memory with generators. I'm just going to stick this in Python, for example. I'm literally sticking it into Bard, just in case the question's coming up. Hopefully, I wonder if we get an example. Yeah, there we go. Okay, start end. Okay, for I in range. Let's have a look. How would that show if it's saved memory, though? That's the question I'm thinking of. I'll just go through with it then, I guess. Which is something like, well, you know what? I could actually. I'll be lazy. I shall be lazy. I'm gonna have a start and an end, and then we're going to have something like this, and then yield I. Now it doesn't like returns you yield. What it does is it gives the process over to other things so that they can continue, and next time you call the function with the next keyword, I believe it is, then you get like the next iterable of it. But anyway, let's have a look here. Def main. Well, it uses a main. I don't really want to use a main. Our test. There we go. Right. Okay. And over there, well, it's got numbers equals generate numbers, but I can't do that. But I'll have numbers equals, and it's going to be our function in our particular case, and then some sort of start 1 to 10, and then something like for num in numbers colon print num, and then we will run our code. So I'm not going to do any if. Here it's got, like in this example here, it's got if name equals main. That's kind of like avoiding that. I don't want to do that. And here I don't even want to call it a main function because we might use it somewhere else. I don't know. We'll reserve it. So I can just call the function that I've written, which is our test, just by running our test. But this doesn't, in my opinion, do a demonstration of why it saves memory. I can run it. We've got the 1, 2, 3, 4, 5 because how have we shown that we've saved memory over there? There is a way to get the amount of memory that's used, but I think the key part of it would be that if you actually had an iterable going in here and not a range start and end. So I think a better example of that would be, and I think it is actually, yes. My underscore range equals, I wonder if this, I for I in, I think I've done this one before, something like that. I for I in range 10, and over here then I can then pass in my range, just something like that, and then here when I come to call it, I will just need now my range over there, because that's what it wants to get back, and over here it will be my range, and I believe it's iterable now. This one here is going to be shorter, I believe, in terms of memory, but I can't remember how to. I might pass on that for a moment, but amount of memory used. I think something like that. Amount of memory used. I'm just. Yeah, here you go. The amount of memory used by a Python program depends on a number of factors, including the size of the program, the data it's working in, and so forth. Blah, blah, blah. But anyway, you have to import sys, and this is what the iterator is really for. So I need to do something like import sys into this, and then do size. Okay, here we go. It's using the numbers thing from above. That's quite convenient because it tends to do that because that's part of the GPT. So I wonder though if print, because that's going to get size of print size, because that's just going to get size of numbers. Numbers here is this small thing. If I do control return, let's see what happens. Let's run them all. Okay, with done the loop. This is a size 200, and I believe that if we do the size over there, in fact, I could probably copy this block, paste it in here, and then shift tab it back over there. Oh, I don't want numbers. I actually want my underscore range and then run it. We see at the moment that this my range is less. So we've seen this before, right? But the whole thing about this is that if I believe if we do like something like that, then all of a sudden, like ignore the bottom bits, but if we look at the top, it's going to go to 1,000,000 now, and it's going to really print it. So okay, oh, we've done it. Okay, fine, that's cool. But importantly, this bit here corresponded to this numbers thing, which came from the yield, and it was giving the items back one at a time, so they always stood at 200. Whereas this one here came from this my range, which initially was actually smaller because it's like 180. But then when you've got big numbers that you're dealing with, this is costing you more in terms of memory. With all of these things is like swings and roundabouts for a lot of this kind of stuff. One thing that I'm going to do, I think if I can get it working, is, I wonder if I've got it, I've got the G-Link thing here. It allows me to have a pen and pencil so that I can draw lines. If it launches itself, it has done. Right, so there we go. So this one here is coming from this big fat range over there, whereas this nice one here which is coming from the numbers over here, which is coming out of this function which is using this yield keyword, and it's taking one item at a time. That's the whole point of it. I believe that it's slower to run it, so you're losing fractions of time, but you're gaining memory. There's always swings and roundabouts with these things. You don't get everything. So I just hit delete to remove all of those things, and hit the arrow things, so I've got my cursor back. So that's that one done. Let's see what else it was on that list of 11 things. We're kind of like more than halfway through. Define default values in dictionaries with get and .set default. Oh, that's going to be an absolute disaster. It's quite because I tend not to use these. Define default values in dictionary with .get and .set default. Okay, well, to define default values in dictionaries, you don't use a .get, you use a .set default. So if I had a d equals, we'd create a dictionary. I wonder if you even need to import default. No, I wonder if it's d equals, because there is a default dictionary in Python, which makes life easy. I'm typing default dictionary usage in Google Bard on the side. Default dictionary usage. It's going to come in here. I'm unable to help you with that. Provide an example of provide an example of a default dictionary. Like Bard is pretty embarrassing. Like I'm embarrassed for Bard today. Or am I relying on it too much? There we go. That's what it is. From collections, import default dictionary, and it gives you this default dictionary where if the key doesn't exist. I think this is what it's referring to. But I wonder if there's a set, how I can use this set default. How can I use the, I'm going to be really, how can I use the set default property there we go. I've just typed in there. That's what I was copying. How can I use the set default property? Okay, it looks like yeah, fine, it was going to be the example. So I'm going to steal it now as well. So you can just do this, which is create your own dictionary over there, and then we can just do d.set default. Okay, so it would have popped up in the IntelliSense anyway. But the thing about this is, which is quite cool, is that something like, well, I mean, they had there in their example C, and then say 3. And then do print D. I don't even know what's going to happen there. Let's have a look. Because it's kind of like, this dot set default hasn't really done anything in particular. Because I wonder if I change that to a B. Let's run it. Yeah, it doesn't. It's kind of like it's just overwritten it. Because this, what I'm meaning is this looks exactly the same as C, like that. Equals 3. Right. I would say that's probably why I haven't used it, or at least not in this context. There might be a different context. So if there is, then like, you know, so like comment in or whatever, or post your views or something, or interrupt. I don't know if you can. But basically, I've never used it because this will do exactly the same thing, but nonetheless, it's there. And I think we can do something like d.get, and I presume that we get a key, basically. So I wonder if I do d.get e, for example, or d, there we go, d.get e, because e doesn't exist. Print d.get e, because it doesn't exist. Well, it just gets us none back. I think that's the thing, is it? Yes, because if I just did print d of e, okay, you can already see that e is not going to be allowable because you've got a, b, and c. It already knows. So I'm going to be abusive there. And what's going to happen now is it will throw us this key error. So get prevents throwing a key error. Whereas here I would have to do an activity. But again, I don't use this get because what I do is try. This is less efficient, but I'll do a try except block and kind of move this up, tab it in, and get rid of the pass. I should actually use it a bit more because I think that cost myself 4 lines of code to do this. In fact, we know that this error here, the proper Pythonic way of doing things is if you know the error, to put the error in. You know what, I'll leave it as that because it will say key error anyway. But when we run it now, no exception, sorry, exception found, and then E, you know, doesn't exist. E does not exist. Key. There we go. So the get is quite convenient because there we go, we got a get. And in fact, I think get allows you to say that this key, or I'll do the same thing, which is key E. Oh, that couldn't do it like that, but I have to put in double quotes. Let's close that one up. Key E does not exist. There we go. Now, well, I've got the none and the key doesn't exist. This does it in 1 line of code. so it's sort of like a little bit nicer, and you've actually, it even gives you the option for an error message. So this is a note to myself. There's so many times where I do a dictionary and I do a try of something, whereas I should use this get statement because it's more efficient. And does it have any comments on it? No. Return the value for the key. Return the value for key if is in. Return value for key if key is in dictionary, else default. There we go. Okay, so that's basically all it's going to do. It's going to give you back. It says give back an integer or a string, but anyway, I think it can do more than that, because if we did have, so like I'll do it here. C equals Darren. If I went and did now C over here. Actually, why is it written a message back now? Because I thought it would write a message back only when it fails. So that's a bit of an interesting one. Oh, that's because I had the print thing there. I actually wanted Control Z. How about using it correctly, which is X that one out, and then put the comment here, because that is the whatever the default is. There we go. So now it does Darren because it's in there. But if I pick something that wasn't in there, then it will go to the default value. So it's much nicer doing this this bit here, d.get, because it gives you all of your error checking. This whole try except block, these 4 lines are now in one line of code. So note to self, that's quite a big win. So definitely want to be adhering to that one. Let's scroll up to the next, which is count hashable object with count hashable object with collections.counter. Another one that I tend not to do, but I'm sure that I probably should be doing. That get one is definitely something that users should be using if you're working with dictionaries. So I don't use the collections module that much, but from collections import counter. There we go. Count hashable objects. So let's create a hashable object, which is a dictionary. So I'm going to create a dictionary like that. That's my hashable object. And then I guess counter of D. I don't even know what this is going to. What does counter do there? Counter creates a new empty counter object, and if given, count elements from an input iterable or initialize a count from another mapping. Okay, C equals counter, that's a new empty counter. C equals counter of this thing, counter. Okay, oh, right, okay, fine, yeah. So I wonder what it will do here. E equals counter of D. That's quite useful. Print E. Not typoing it. There we go. Print E. And it's sort of like, well, it's done B to A1, but I guess, well, it won't do this because if I do B, you can already see the thingy there. I don't know, it should be maybe B100. I wonder what happens there. Yeah, because all it's doing is that. Because this counter example here took a string in. Let's have a hover over it. Because it gave you some examples here. count elements from a string is what it did there, and it's sort of like then it gives you a nice list back. It gives you this back, and then you can even sort it. So that's all that the counter method seems to be doing there, which is oh, I think that's why actually, so right, so like when I run it down the bottom, you sort of like see it there. R occurs twice over there. If I do the whole pen thing, R here occurs because there's two R's in Darren, and everything else just occurs once. Like D occurs once, A occurs once, because there's one D, there's one A in Darren, and so forth. So what it's done is it's created that's that hashable object that it's talking about, which is this thing here. So it's taken this string and it's brought it into its components, and then you could do a little bit more than that, because you could, I think you could do, if I hover over that in the example, I quite like it. Quite a lot of the built-in functions should be like this in Python, where it's all that gives you a bit of a use case as well. But over here anyway, so it gives you, so you've got common, through, most common. Yeah, I mean, there's lots more things that you can do. I wonder if I do E dot third time lucky, we can see all of this stuff, the most common, but we know already that it's that this is a dictionary, and it's going to give us the item, because we could do a search for it. So this whole collections module is really useful, and this one function, function in it effectively. But there's other things inside of this, and we can do e.mostcommon on our dictionary. I wonder if you could just do that normally on it. I know, because it's a counter object. If I hover over it, here is a counter object, and the counter object has the most common, so it's not just a regular dictionary. So I can't up here, for example, do the most common, because that doesn't exist. But if it was a counter object, you can, and it will print out what the most common thing is. And I wonder again if I can put, I probably can put inside the brackets, but I'm just checking. I should really, yeah, most common 3. I'm just going to do most common 1. There we go. Because then I'll just get the most common object in Darren, which is the double R there. He's picked out the 2 R's. So that's hashable objects with the counters collection, kind of like done. Format with F strings, that's like a no-brainer. In fact, I say it's a no-brainer. And I know that I didn't do this multiple times. Sometimes I don't always use, I use F strings a ton of a lot, but I didn't in my code, and x equals 10. Let's just do this. X and y equal 10, 20, and then so I print F string, and then to do the F string, something like this, and x is half the value of y, full stop. So something like that. It enables you to conveniently put your variables inside your strings like that, and there we go. X is half of 20, and you don't then have to worry about spaces and stuff, because it's all part of the normal sentence. So, an example of that would be here, which should really be in an F string, but I was too lazy to do that. But if I did put it into an F string, it would now look like that. And if I ran that, we now get the key E does not exist. And likewise over here, I presume, well, there was no need for it because that was just a complete string, but where I did print statements before and I was kind of like lazy about them, if I did, because I know I had one above, like here, for example, although I don't classify this as lazy, but time taken, but you'll see where the, here's the convenient part of it is, it looks like that. It's easier to read this one than it is to read that one, but when I'm building it, sometimes I still don't do it. So it just depends, if I run it, you've got the time taken in both cases. I'll just extend it a little bit across there, but the time taken and time taken, so they don't look any different. And the F string is supposed to be a tiny bit more convenient. So that's really that. I'm not going to do too much else on that, but you're aware that F strings are available. So I guess let's just go on, which is, so let's just go on. Yeah, concatenate with join, X. There's no, again, there's so many operators on strings. We'll have a look actually, but what this is talking about is something like A equals, I'll use X and Y because I've used it the whole time. X equals hello and Y equals world. And then we can do print X plus Y, and that is not concatenating. And one thing that will happen is we'll get hello world all joined together. So we have to do this. This is the concatenation, which is, we'll put a little space in between. There we go. Right, but we could do X. Well, let's do print on all of this to start with. Print X dot join Y. I wonder even if we can put in the joining part. No, so I did do X dot join Y. I wonder what actually happens there. That's an interesting one. Why has that looped itself around? Z equals X dot join Y. Print Z. Is that going to be any better? No, why is it wrapped it around? Hello world, hello world, hello world. Okay. Yeah, right, that's why. So let's get this right. Oops. Yeah, it'd be something like space. There we go. Join X and Y. That's the proper usage of it. I have to look it up because I don't use it that often. But now when we print Z, oops, takes exactly. The string dot join takes one argument. Okay. Dot join. Concatenate any number of strings. The string whose method is called is inserted between each. The string whose method is called is inserted between each given string. Hello world. Okay, still get the same error. That's why. Annoying. It will be X and Y. That's why, because this here inside the join takes a list of items. So yeah, there we go. And that's kind of like why I don't use it, because it's just faster to do this, but I think it's more efficient in Pythonic to do that. And you're joining it, and like you could put like join things like however you wanted to. Now, so when I say I don't use it, I won't use it for short things like this because there's no gain. But if you had a massive sentence, you know, hello world, how are you, and so forth, we wanted to join like lots of things together. You've got all of this stuff here. So where there's an overhead over here, we can see that this line is longer to start with, right? So there's a cost saving, but that soon starts to diminish because if I had an X, Y, an A, B, C, D, E, X, Y, Z, whatever, over here my print statement would start to become massive very quickly and very messy, whereas this join thing would be quite efficient. And the other thing is this join just works on a list, so you can sort of like put a whole list in there and join it with kind of like, you know, dashes or something like that. So the join is a lot more powerful. So maybe I could do a better example, something like my list equals something like cheese, things that go on pizza, pepperoni, olives, onion, have a onion list. But anyway, now we can do Z equals the same thing with, we'll put a dash in between them, and then a dot join, and then my list. So be something like this, and we'll stick something else on there. What else can we put on a pizza? Jalapeno peppers. I don't know how you spell that, but something like that. And then print Z, and when we run it, you know, now you can see where the advantage of this join is, because it's, you know, join them all, done anything. And the alternative would to do, you'd have to put a plus this, plus dash that, plus dash that, or something in it. So this dot join is powerful. But one of the things I was going to say, this works on any sort of string here. Like, so we've got a string which is X. X is a string. Well, you can see we can capitalize it, C, fold, center, count, encode, ends with, find, format. There's tons and tons of methods. So I don't know why join was picked, you know, as something that's special. There's a lot of great methods for strings, and you just kind of like have to know them. But that's there. So let's just go on, and what's next? Merge dictionaries, Python 3.5 plus X. So anyone using old versions of Python should go away. If you're using an older version of Python, if you're using Python 2.7, then you are in the dinosaur ages, because that became legacy a while ago. But yeah, like how do we join dictionaries basically in Python? So I haven't really joined dictionaries that much. I normally join the pandas data frame. But let's say we've got, I can nick one dictionary and then maybe create another one somewhere, because we had a dictionary. There we go. So let's merge our dictionaries. That's our first dictionary, and our second dictionary will be something like and C and D. I won't even, I will change value just to show that, you know, 3 and 4. You know, one thing is, it's a bit weird, is kind of like, well, I don't know actually, could you add a dictionary? So we still like want to do like print D plus E, right? It's like we'd want to sort of like do that and run it, but we don't. We get this unsupported operand type for plus with dict and dict. It doesn't know how to do it, so it's kind of like, how do you join a dictionary? So merge dictionaries, bang, merge dictionaries with D1 and D2. Well, the double star, basically, this bit here is the important bit. There we go, that's the joining version of it. I wanted to kind of get that up because, so basically we'll create this, we'll have this new dictionary, and then it is the first dictionary unpacking the first one, and then double star on the second one. And I wonder if, no, it doesn't say it here, but it should actually say, but maybe I will put it there. No, it doesn't. Oh yeah, it's called unpacking. So sure, you can merge dictionaries in Python using the unpacking operator. The unpacking operator takes a list, if it was going to be a list, or a tuple. A tuple is kind of like a list, an immutable list, or a tuple of dictionaries, and merges them. It should be a tuple, or it should be a merging as well, dictionary as well, and merges them into a single dictionary. But generally, this unpacking thing, it unpacks all of the items in the list. So I think that we could, but anyway, let's just do now, we'll print F, and this will now work if we just go, because we're going to pack D and E. There we go, and it works. If we did pack D and D, what's going to happen is we're just going to get D back, because the second D is going to overwrite the first D. So it's just going to look like a D. So that's why we want, because remember, the keys in dictionaries have to be unique. So there we go, we unpacked a D and an E there. And I was going to say, like, if we had a list, so X equals 10, 20, 30, 40 and 50, if we had a list there, print, I wonder if you can star X. No, okay, it doesn't do it because it must be a mapping. Okay. I wonder if you could do like A, B, C, D, E equals star X. Because I think, no, it doesn't do it. Got to be careful, but I know when you pass arguments in, you can, they're like the keyword arguments. Well, maybe it's only on a dictionary actually. Maybe we do a star of D. No. Okay, I'll ignore that for now. I won't go into others because we've got to move on. But the double star does this unpacking, and then it's kind of like unpacking a dictionary and then unpacking the first dictionary, unpacking the second dictionary, and joining them together, and then giving us a result back. So I will leave side commentaries out on that particular one, and that's just that. Let me just delete that because I don't like delete all these erroneous things there. So that's our merged dictionary anyway from that. What's next on the list? Scrolling right to the top, the last item. Simplify if statements with if X in list. Okay. X, take that out. 11 things to do. Just go to the last one. There we go. simplify if statements with if x in list. So let's make a list. I'm going to go and nick our list. God, our list is so far up there now. Right, if 20 in x, because that's our list, print found it, ... I guess that's the example. Simplify if statements with if x in list. That's all it could really be talking about, is simplify if statements. I mean, it's going to do that if, just stick this on the side, but 21 is not in list. Oops, is not in x. Print did not find it. There we go. And likewise, if this was like 30, it won't print that. So you just go found it for the first one, and there's no did not find it. I could do that, else print found it ... So there we go. It's found it, and if we do 31, it hasn't found it. So that's basically it. That's all of the stuff. So that was this little website, which was over here, which was 11 tips and tricks. Must know tips and tricks. They're not must knows at all. Well, there's a couple of very useful ones, but I'm not going to call them must knows. I mean, I think this is general knowledge, so we know that anyway. This one's quite useful, but you'd look it up, you'll ChatGPT it, because you'll probably try and add dictionaries at first, and then it would throw you the error, and then you'd look it up how to merge dictionaries. There's different ways of joining dictionaries. I don't think that's the only way, by the way. Or I know it's not the only way, but I'm not going to go into other ways. That's the most modern way of joining dictionaries, I believe. Concatenation, again, I pointed out there's tons of methods on strings, because you got all of these methods, tons of them, as in literally tons, right down to here. I don't even know what it said. Fill is a padding. You give some paddings with some zeros on the left hand side. Yeah, but anyway, so concatenation. Yeah, but you could use a plus sign. For small things, you'd use a plus sign. You'd use join for bigger stuff, as mentioned. Hashable objects with counter, that can be useful. That can be powerful. There are other ways of doing things. But if you are going to do, there's two things. There's collections. There's also iterables. There's combinations as well, I think it's called. I know that's in the itertools module. So there's itertools and there's collections, and they're both modules that are quite useful in Python, basically. And one useful thing there was the counter function. Then this .get, that saves you having to and set default, but the get saves you throwing an error or having to do the try except. Now, okay, I don't use get a lot because I just make sure that the dictionary key does exist. Therefore, I don't have to do the try. Therefore, I've never have to worry about the get. But if I did have to do a get on something and to see if it did exist, it's better doing a get than it is a try except. Because it does all the handling, everything, it just makes your code smaller. So that was a good one. Generators, yes, you'll use them in certain places where you've got massive lists that you want to loop through. In those cases, you are certainly better off using generators, because you might even, your code might even like grind to a halt at some point, but with a generator it won't grind to a halt. Store unique values. Okay, that's kind of like a nice trick to have. There's other ways of doing it, but you could kind of, I guess again, you probably look that one up. What have we got over there? Sort complex iterables with sorted. Yeah, I'm not sure that there'd be another way. I mean, you've got the x.sort, which is in place, and then you've got sorted, which creates a new piece of memory. I think the iterable can be more complicated than this one. So, and maybe that's what sorted's for, like you could put in a dictionary as well. So, you know, I could put like something like example of sorted with a in Python. Example of sorted with a dictionary in Python. It's just running, and there we go. So that is created a dictionary, and then we could do sort dict items, and it will sort your dictionary in terms of its items, A, B, and C, whatever. The items weren't jumbled up here, so they came back in the same order. But if they were jumbled up, or if you had a set, where we had our set actually, well, we did do it on our set. We had to sort it. We had to sort our set somewhere. Okay, list comprehension. This is very, very common, using list comprehension instead of for loops. It's the modern way of doing a lot of stuff. List comprehension is quite useful. And you can actually put if statements and stuff in there as well. So you could do I squared for I in X if I divided by 2 equals 0, right? So you only do it for the even numbers now, and that will run. And I wonder if I printed Y. I don't think I printed Y the second time. I print Y. Our list now here will be, there we go. I squared for I in X. Because they're all even numbers. They're all multiples of 5. They're all multiples of 2. Are they all multiples of 3? No. So, I mean, maybe I'll do something like that just as an example. But yes, return back only 900 because it's only squared this one now. So I was able to put an if statement in there as well with the list comprehension. It makes it a bit more powerful. Here you'd stick that equivalent list. You'd do something like if I percentage of 3 equals 0, you do something like that, and then you do y.append. So that's sort of like the difference. You can sort of like see again now that this is a bit cleaner and easier to read. So, you know, that's where the gain is, should we say. Although if you're doing more complicated stuff, which you can do, it starts at a certain point of complication. That's where you start jumping into your regular for loops again. So I don't know if I'll delete it. I'll just leave that there anyway. Finally, iterate with enumerate, and yeah, again for IV and enumerate, you know, print IV. Should iterate with enumerate. I think, well, you could actually enumerate. So you could do y equals, and then list comprehension. We could combine the thing down below. I squared for I in enumerate X. It'd be for IV because there's two things coming out of there. In enumerate X So we do v squared for I, v, and x if I percent is, so for all even items, so this one here, this one here, and this one here, will square those. If I percentage 2 equals 0, there we go. So for every even index of I, so 0, 2, and 4, go along and give us v squared. So we'll get 10 squared, 30 squared, and 50 squared, hopefully. And that one, we can do print of y, and Python will go along and do it, and it will return. And what's nice about this list comprehension is, so I've wrapped two things into one, is it returns the item back straight away into a list. You didn't have to create this dummy list or anything. So you can see here that we've kind of like done, the whole for loop thing. We've stuck an enumerate in there. Our functions become relatively complicated, but at the same point in time, we can read it. And the way to read it is, this is the bit of the for loop. So this is the same as, this is for IV in enumerate X. And actually when I hovered over it, you can see that this one got colored as well. So literally this for loop here is exactly what's gone into this list comprehension over here. And where we wanted to square it, like if we did square it, we do this is the v squared. You'd actually have to put something here, this dummy variable, and then you have to do something dot append, and then also this if statement. We'll do the if statement here, so we can see how much shorter it is. One nice thing that we can do with this comprehension, just to show if it wasn't clear, is we can actually break it down in lines. So you could do something like this. V squared, for v squared in enumerate, and then if, there we go. That's a nice looking list comprehension. So Python lets you do that. It doesn't throw any errors because it's all inside the brackets. Yeah, that's kind of like really it. And I think we'll leave it there. There was 11 things to do in Python, in like fancy different ways. And yeah, I'll leave it there. I'll stop the stream. Oh, just I guess before I stop the stream, I guess if you do watch it, like it, and also it'd be nice if there's things that are wrong. I'm hoping there's nothing wrong there, or if there's improvements that you think should be added, and kind of like leave some comments. That'd be quite useful. And that's it.